Welcome to Protect Your IP with Runtime Apps. Hey, I'm Eric, and I recently did a video on how you could, go behind the scenes and flip the exposure policy flag, at least on on-prem PC, to enable you to download the source code from an app that had where download was not allowed. And I got a fair amount of comments, both under the video and through other channels, saying, "But hey, this is Microsoft. They should do better. They should encrypt. They should do a lot of stuff." And I kind of already gave the answer to that question in the other video, but in this video, I'll show you the answer. And the answer is called a runtime app. And what is a runtime app, you might ask, which is a great question. Let me actually show you something here. So here is, I got two different apps here. So if I do, I have two apps found here. It just took my toolbox. So my toolbox app, Hogart_toolbox and version on.app, that is a normal app file. So if I open that with 7-zip, it's a zip file, and I can find the source code in here. I can go look at the source code, and this is all good and well. Like a normal app file. But you see the other one here. So if I do the same thing, I try to open the runtime toolbox app file. I get an error on a different screen. This is not an archive. So clearly it's called an app file, but it's a different type of app file. And if we try to do, if I type, let's output this to the screen. You can see this starts with navx and then navx philcats zip file something. Because it's kind of a zip file, but there's also a video on that somewhere. But if I do the same thing here, let me actually make sure we do it from full screen. It still says navx, but then there's no zip, and it says navx.nea, and then it's just garbled, the rest of it. So it's a different type of file. This is an encrypted file from it's an encrypted app basically, and that's pretty cool, but it's more than that. So you might ask, how to create one of those? And so somewhere at some point I found a script out on the interwebs, and I looked to see if I could locate where I got this from originally. So I have edited it away, and I couldn't find it. So if this is your creation that I have built on, please give me a link below so I can give you credit. But basically what this is a PowerShell script, and the idea is that it loops through all the versions of Business Central. Downloads builds a container with that version of Business Central, a Docker container. Then in this case, because we got two apps, the toolbox, so it installs the two app files that I get out of my pipeline, install those into the container. Then it uses a part of BC container helper called BC get BC container app runtime package. So it asks the server, hey, that app file we just installed, give me that again as a runtime app. So you get that back, I assign it, and then I copy it to my archive somewhere. I stop and kill that container and goes to the next version. So at whenever there is an actual release of the toolbox, at some point this runs, and then that ends up building the runtime apps that you can go download if you want to run my toolbox on-prem. So all the magic happens in this function, get BC container app runtime package, where you get an app. But what's actually in this app, you might ask? It's encrypted. What we know from Microsoft is that it's version dependent. So you cannot take a runtime app from one version of BC and use on another runtime on another version of BC. You cannot upload a runtime app to the cloud. The cloud will only accept source apps. But let's see if we can figure out what's actually in it. I'll create a folder here, go into that folder, and then I will do something like this, perhaps. Boom. And then let's start Visual Studio Code here. So by magic, I have now the content of a runtime app on screen. And we can see that some of this looks very familiar. Add in, bin, entitlement, layout, logo, translation, media listing. There's a logo file, navigation. There are the places where apps have logged, have added content to the search menu. The nav xmanifest.xml is the same as the app.json file, just the XML version of it. I can't remember if we can make this look nice. I don't think we can. Not nicer than this. So we got all the usual stuff. We got the symbols file here. And we got translation, we got a logo, we got layout, and there's apparently no layouts here. That's report layouts. There's no reports in the toolbox. Entitlement, it's entitlement. That's all good. And bin. So a normal app file has a source folder. There's no source folder in this. There's only bin. And if we do look at bin, we can see that code page of the files almost look like, you know, the old days when you got text objects out of nav. But it's called .cs, so C#. And it is C#. And what we can see here is in reality this is the so the way, if you don't know this, let me explain how Business Central works, how AL works. That the compiler, when you compile AL, in its reality is not a compiler. It's that's the wrong word. It's a transpiler, because what it actually does is that it takes your AL code and then it outputs C#. That C# is then fed into the C# compiler and outputs what is known as IL, intermediary language, that then is fed into the just-in-time compiler runtime part of the .NET platform that will emit machine language, machine code, and then execute that. So it's actually a fairly long pipeline before what you do is actually executed. But the content here is C#. And I think if I have done this correctly, hopefully I randomly took page 452. I did. So here is a option lookup list in the toolbox. So I think it's part of the object browser where you can actually run any table, but if you click lookup on an option field, I have to create a a list of what the options member are on the option field. So I do that. So there's a bit of layout. There's no actions. There's a procedure called getRec and there's a trigger called open page. And there's some options. So how is that? Let's see if we can, okay, maybe I can do this. There we go. Almost makes sense. So maybe like this is better. So we got a public seal class. So there's a class called page, which is a nav form, by the way, not a page, it's a form. And there is a couple of constructors and initialize components, which I guess is almost a leftover from the Rotator client. I'm not sure. Then it has a nav. It declares a variable called rec and another variable called xrec and another variable called curPage, which point to this. So the object itself. It has an on invoke function that does something. I guess that might be, this is actually the, so this ID apparently is this get function. That calls, no, this is a way to call it. Anyway, well, but anyway, we're not really analyzing how Microsoft is generating C# code. I think that's a whole different video if it is a video. What I'm trying to, so here we got the getRec function and we got the open page trigger. So as you can see, it's a kind of the same content, but it's certainly not the source code anymore. And yeah, our open page has a few lines. So statement 1 is if something and get filter and then return, that's probably that. Then statement hit number 2 is an evaluate, and then statement 3 we're invoking something on the record, parent base rec invoke, and then we're also doing a set current key here. So you can see that the content of the runtime app is not your source code anymore. Maybe if you really spend a lot of time, if you have access to the source code here, which you don't because it's encrypted and nobody can read this, then you might be able to kind of figure out what's going on. But it's a really weird to trying to, you know, reconstruct code from this. Anyway. Nobody can see that code, so it doesn't really matter. So, long story short, if you want to protect your IP, this is the way to do it. You create a runtime app, and that is what you distribute. You can be inspired. Let's hope somebody puts a link to where that originally that script came from. But the idea is that I just run this and then it goes through all the supported Business Central versions that my app supports and grabs every single CU. So, and then after a couple of minutes, it had created, 20 different Docker images, created the apps and deleted the Docker again. I got a whole folder filled with app files ready to go. That's how I do it. So I guess that was actually AL hacking going on here. But if you want to see some AL programming, this is a video for you. Go check it out. It's a good one. I'll see you there. Take care. Bye.